Okay, here's the system that I have. We did an example yesterday, guys, and I would like to get just to emphasize it a little bit with giving you a couple of other examples. Um, because what we're dealing with is mechanical equipment. When we deal with mechanical equipment, we need to size these 5 things that we've been going over and over again. You know it now, you're good for the whole year. You don't, you still have 2 chances of getting it when we go to the industrial and commercial. When we go commercial industrial, we'll be doing 3-phase. So what I picked, guys, I picked 2 pumps or fans. These could be fans, exhaust fans. They're big for exhaust fans. Could be pumps, motors. Okay. It's an A and a B. One of them, they're both running at, this one is running at 240 volt, single phase. This one is running at 120, single phase. 10 horsepower, 5 horsepower. They're all coming from a 240, 120 single phase, 100 amp panel. A little bit too much for a 10 horsepower 240. And I need to size the branch circuit, the overconduction device, the disconnect, the controller, the overload, and the equipment running conductor for each one of these pumps or fans, anything that has a motor in it. I decided to use a starter/disconnect, guys. There's a combo starter/disconnect that we use. Basically a box that has a disconnect on it, and a controller, a magnetic starter, and an overload. I am using NMB cable wiring methods. Very, very important. I'm using what type of wiring methods? NMB. So I can't go to the 75-degree column. I have to go to 60 because NMB is rated for 60. So that's basically what the example that I have. I'm going to go size these 6 things for these 2 motors. Any comments, any questions? Do you guys have enough? I'm going to give you a few seconds to sketch them, and then we'll go over the calculation. And this is continuation what we did yesterday. Any comments, any questions before we go ahead and start on that? So when we were talking about the hydro massage bathtub, it's a pump that applies to it. When we were talking about the garbage disposal, it's a motor that applies to it. When we were talking, guys, also about the exhaust fans in the attic or in the bathroom, exhaust fan only, that applies to it. These are bigger horsepower, so the application you have when it's a smaller horsepower, guys, there's a little, you can do it with cheaper equipment, obviously, with just circuit breakers and switches. With bigger horsepower, you have to have a full spiel disconnect, controller, overload, and overconduction device. Any comments, any questions? The green is the equipment running conductor that coming to ground the frame of this motor. Let me know, guys, when you are set with it, so we can go and start. Here's what you guys are looking at. That box that disconnects, looking at a disconnect like that. When you open it, and I'm sure you wired a few of them, what you're looking at right there is a disconnect to disconnect the system, a circuit breaker to protect it from overconduction device, a contactor, that's a controller, and an overload. Did you see that? That's what you buy to power major equipment. This is a 100-degree 3-phase. They have a smaller version of the single phase part. So this box that you're looking at here, Matt, is really that box here. Okay, cool. Should we go? Karen, you good? All right. So let's go size the equipment. So I'm going to go directly into The first thing you need to do, guys, for these motors, obviously, is to go find the full load current. So the full, like we did yesterday, if you go to a 10 horsepower from 430.248 at under 240, like we did yesterday, you're going to end up with 50 amp. 50 amp. You got yourself a 50 amp. Right? That's just finding the full load current. And I hope you guys remember. I think I have it here. There you go. No, that's not here. I don't know if I have it. Okay, I don't have it. But when you go to the table 430.248, you get you a 50 amps. Then for branch circuits, guys, you use a 1.25 multiplied by 50, and that will get you a healthy 62.5 amps. So why do we multiply by 1.25? Because it's continuous load. We multiply by 1.25 because it's continuous load. Okay? It's a continuous load. So we multiply by 1.25. All right, then I take the 62.5 to 334.80 NM cable, and then you have, then from there, you go to table 310.15 B16 under 60-degree column. Anybody knows why we're going under 60-degree column? Because it's raw mix, right? Raw mix is 60-degree column. When you go there, guys, you are going to find, you need the following. You need a 4-2, an B cable. A 4-2 and an B cable. 4-2. Number 4/2. Two conductor number 4. Why two conductors? We don't need a neutral. So that's the size of the conductor that you need. I can't emphasize it's an NM cable. Because it's an NM cable, you guys do not need to size based on 75. The overcome protection device is a circuit breaker like we did yesterday, Adam. For circuit breakers, we use 2.5. So 2.5, you multiply it by 50. That will get you a healthy 125 amp. 125 amp. And you take 125 amp, take this one to 240.6, and then that will get you 125 amp size. It's already a size. It's going to be it will be a 2-pole circuit breaker. This is a 2-pole circuit breaker, and this is coming from table 430.52. You guys remember that? That's where the 1.25. Any comments, any questions? We did this yesterday too. So if you look at, we said for circuit breakers, you're going to go to the 250, right? Remember that 250? You go to 250 to find it. Now, that 100 amp circuit breaker will not cut it then. I'm just going to go change my size. It's a bit smaller size here. So let's just say 300 amp. 300 amp panel. Okay. Any comments, guys? We size the overcome protection device and the branch circuits. Number 2. Cool. Now you can go. Everybody's good? Good. Okay. Now this is what we size. This is where it tells you guys if you go to an NM cable, it will tell you it's rated for. Can you see that? 60-degree column. So I have to go to 60-degree column because that's what it tells me for NM cable. Okay. This is the amps. This is just a couple of snapshots for a 10 horsepower, 50 amps. Right? These are just the snapshots where we got this information from. Okay, let's go to the disconnect. Next, number 3 is disconnect. For disconnects, if you guys remember yesterday, we said for disconnect, you go to 430.110. It's very simple. It takes the 1.15, multiply this really by 50, and that will get you 57.5 amps. And from there, you take the 57.5 amps, take it to DeWalt 312, 3-12, and that'll get you 60 amp disconnect, non-fused disconnect. 60 amp non-fused disconnect. There's no fuse in it. Exactly like the one that you're looking at here. Any comments, guys? Any questions? And again, we did example yesterday. I thought just to emphasize it with another example today. The controller is so easy, guys. You take the 10 horsepower at 240 volt, single phase. Take this one to DeWalt. If you take it to DeWalt 6-4, and that will get you a healthy NEMA 3, NEMA number 3. So Matt, what you're doing is you're looking at, here's the NEMA. That right here, the magnetic, that's where they size them by NEMA 3. If you don't have DeWalt, Derek, or what you do for me in the test, you just write 10 horsepower, 240 single phase. Did you guys hear me? That's it. Overload. Next one is overload. So for overload, you go to 430.32. We guys have been there. You're going to take 1.15 because we have no idea what the service factor times full load amp name plate on the nameplate, and you take the 1.15 times full load amp nameplate is 45. I'm going to say the word here, name plate given. Did you guys hear me? Given. I'm giving you, it's 45. Okay? And when you do this, it ends up with 51.8 amps. So your overload will be set at 51.4 amps. 51.8 amps. The last thing, guys, is the equipment ground conductor. You go to overcurrent protection device size. That was 125 amp. Take this one to table 250.122. That will get you one conductor, number 6. Number 6. AWG. Hopefully that conductor will be part of your UNAM cable. That conductor will be part of your UNAM cable. So we're not going to have one conductor, guys. Typically it will be part of your UNAM cable. 250.122. Number 6, AWG, part of your UNAM cable. Any comments, guys? Any questions? Now, if you missed everything that I've done now, there's another chance to do one more. So you can see I'm going over these examples, guys. Here's where the the table 250.122, you go to number 6. I want to emphasize that these are PDF and on the network too. So for your review, okay, here's the 115 for the overload. Okay, now let's go to the second motor. We're going to repeat the same 6 steps for the second motor. Hopefully it will sink in, guys, and I'm sure it will. So for a 5 horsepower motor, 120, I want to emphasize the word this is a 120. 120. So first, if you take 5 horsepower at 120 volt, take it to table 4, 30.248 under 115 volt, you get yourself a healthy 56 amps. 56 amps. 56 amps. Everybody knows where the 56 amps came to be? That's from basically from the full load current of that equipment. Let's go back here. I think it should be somewhere here. There you go. So for 5 horsepower, can you guys see where the 56s came to be? Right here from this table, which is 248, 56. Okay. Now, branch circuit, the same thing. Calculation very easy, guys. When you do branch circuit, 1.25, multiply this baby by 56. That will get you a 70 amp. And then you take the 70 amp to table 310.15 B16 under 60-degree column. Why? Celsius, because it's Romex, and it's an NM cable, so that will get you number 42, AWG NMB. Is that true? 42? What was the first one? The first one was, okay, let me check that. So we have 70 amps. For 70 amps, 42. Yeah, the first one then is wrong. Why didn't you guys bring my attention? This one.
First one would have been 4 as well, because it says 6, and we got the 55, and we had 62.5.
The first one. Oh, I see. Okay, I got it. Okay. Yeah. There's the 2 horsepowers are, one of them is twice, but the voltage is different. Got it. Okay. That's what for a second it made me. Okay. You guys know why one of them is twice as big as the other, but the conductor is still the same, because the voltage of the big one is also big. So that we compensated by the voltage. For a second I forgot that the voltage, we're using 120 here. Had this been 240, that's no way you can do that. It will be smaller. Okay, so that's good. Thank you. I thought I missed something. No, I didn't know. Okay, so then next is overprotection device. Circuit breaker, the same thing. You take the 2.5, multiply it by 70. Not the 70, sorry, the 56. 56. That will get you 140 amp. And then you take 140 amp, take it to 240.6, and that'll get you 150 amp. Single pole. I don't know if they even do that. Circuit breaker. So I'm not sure if they even do that 150 amp single pole. I doubt that they will do it, but does that make sense? Again, put question mark if it's doable. 150 amp circuit breaker. That's number two. Should we go to the disconnect when you guys are ready? Disconnect. Same thing, I'm repeating myself here. So the disconnect is 1.15 multiplied by 56. That will get you 64.4 amp. And then you take the 64.4 amp, take this one to the volt 312, and that will get you 100 amp. 100 amp non-fused. Non-fused. It has to be 2-pole here, but we use only 1 pole. Controller, same thing, guys, 5 horsepower at 120 volt, single phase. That's what you do. Derek, you just write this one for me, and you're done. Now, when you have the volt, then you take it from there to the wall 6-4. That'll get you NEMA number 3. Even I can't emphasize these two sizes, guys, are too big for the voltage that we're using. Which one?
What is that thing? Below the controller. What is that? What's that?
5 horsepower.
5.
5 horsepower. 5 horsepower. The last thing is equipment. So we got the controller. We're going to go to the overload. Shall we? Yes, sir. Buddy, Karen, good. Okay. So let's go to the next one is the overload. I have no idea what the overload is, what the size is, so I'm going to take 1.15 multiplied by the nameplate, 50 amps. Where did this 50 amps came to be? I'm going to say given nameplate given. So that will get you 57.5 amp. 57.5 amp. Done. The last thing, guys, is the equipment running conductor. You take the 150 amp circuit breaker, take it to table 250.1, 2, and 2, and that will get you one conductor, number 6, AWG, and that will be part of an MP cable. That will be part of your NMP cable. Any comments, guys? Any questions? Any comments? Any questions? So that's 2 examples for pumps and fans and anything that need these 6 things. Can you guys assure me that now we know how to emphasize these things? Okay. I do have 2 heaters for you, water heaters. We're going to do the same thing for 2 water heaters. So if you guys are going to sketch this one here, I have for the water heaters, almost the same thing. I have 100 amp, 240, 120 single phase panel, or it could be more. And I need to size the branch circuit for a 5 kW 240 and a 2 kW 120 volt water heater. Both of them are water heaters. I need to size the branch circuit overcompression device, the disconnect, as well as the equipment grounding conductor. No controller, no overload. No controller, no overload. The controller will be provided by the manufacturer. The overload will be factored into the circuit breaker, I guess. So we switched from fans and pumps and exhaust fans, pumps and garbage disposals into heaters, water heaters. We need to find these four things for two water heaters. Any comments, guys? Any questions? Give you a few seconds to sketch them. So now add that I'm using NMB wiring method. The wiring methods, I'm still using NMB. I'm using NMB. And I will bring to your attention, guys, both of them are single phase, but one is burning at 120 and the other one is burning at 240. Why did I pick these two voltages? Just to get you to understand how to manipulate, work with two voltages on a single phase. Let me know when you guys are good. Next time I'm going to make a copy for you, like I did last time. Makes it easier. Make a copy, at least the graphics. But I want to remind you guys, these will be PDF'd on the network too, so you should be able to see them. Okay. All right, so let's go ahead and size the branch circuit. We reminded you guys that the wiring methods is NMB. I'm using an NMB wiring method. I need to do the branch circuits. The first thing you need to do is find the current. I equal for the load A, 5K divided by 240 volt, and that will get you a healthy 20.83 amps. That's the amps of this equipment. It's continuous load, so 1.25 multiplied 20.83. It's a continuous load, so get you 26 amps. Okay, and this is coming from 422.10A, 422.10A, about 10A. Continuous load. So it's a continuous load. That's your reference for this number. Okay, then the rest is history, guys. We're going to go size. I have 26 amps. I need to go to table 3, 10.15, B16 under 60-degree column because it's Romex, and that will get you number 10.2 AWG NMB cable. 10.2. Okay, Now let's go to the overcome protection device number 2. So here's where the 125 guys came to be. The references that we just talked about for branch circuits. All right, now I want to go all the way to place this. I need the size overcome protection device. For the overcome protection device, guys, if you go to 422.11e, 422.11e. If you go to 422.11e, it tells you the following. If the full load current of the appliances is more than 13.3, you multiply by 1.5. So because it's a non-motor, 1.5 multiplied by the full load current of that piece of equipment was 20.83, and that will get you a healthy 31.24 amps. Where did that number came to be? This is directly from the 422.11e. Then you take the 31.24, take it to 240.6. If it's not a standard, you're allowed to go up to 35 amps, up to 35 amps. Or you can go down to 30 amps. And I want to put up and down 35 amps or 30 amps. And I want to tell you which one we're going to use. Okay, so when I size my overcome protection device, Derek, I can, the code allows me to go up if I want to 35 or down. But I want to remind you the size of the conductor that I already sized was number 10. Can I go up on number 10, 35? I can't go 35 amps on number 10 because number 10, guys, is limited to 30 amps. You can see there's a decision to make. So if I go up to 35, I have to go up my conductor. So that's why I would go to 30 amps here. Here's my 30 amp circuit breaker because my conductor is number 10. So I go to 30 amp because my conductor is number 10. Could I have gone to number 35? Yep. What do you need to do if you go 35? Then you have to go change your conductor to number 8. You're allowed to go to 35. You don't have to go to 35. There's a difference between allowed to and have to. Okay. So that's number 2. Any comments, guys? Any questions? So it's going to be a 30 amp. Okay, did you guys highlight the 30 amps? 30 amps. That's my 30 amps. Let's go to the branch circuit. Am I going too fast, Adam? No? Okay. All right, disconnect. Let's go to the disconnect. For the disconnect, guys, the way I size the disconnect, for this equipment, since it's continuous load, I go 1.25, I don't have a reference for that, multiplied by 20.83, and that will give me 26 amps. And 26 amps, take it to deep volt 3-12, that will get you 30 amp, 2-pole, non-fused disconnect. 30 amp 2-pole non-fused disconnect. So I treat it like a continuous load sizing. The last thing, the equipment air conductor is very easy, guys. You take the overcurrent protection device that you have just came up with, which is 30 amps. Take this one to table 250.122 and that will get you a healthy one conductor number 10 AWG in an MB cable. Remember, we're using a cable, so it will be part of the NME cable. You don't have to pull a separate one. Does that make sense, Matt? You're not pulling a new one. There's a cable. Two of them are going to be 2 huts and an equivalent conductor number 10. Okay. Let's go to 2B, guys. This is now we're repeating ourselves, really. For 2B, I have you have to find now the current for this guy. I have a 2K divided by 120, remind you, will give me 16.7 amps. Then 1.25 multiplied by 16.7 amps. Again, I'm repeating myself, 21.9 amps. And if you take 20.9 amps to table 310.15 B16 under 60 degree, and that will get you number 10 to AWG and MB cable. Done. See how easy that is? Okay. For the overconduction device, guys, the same thing. You're going to take 1.5, multiply this one by 16.7. That will get you a healthy 25.1 amp. And when you take 25.1 amps, take it to 240.6, that will get you 25 amp single pole circuit breaker. It's a single pole. Can you guys, everybody knows why single pole circuit breaker, not two pole circuit breaker? Single pole circuit breaker. Okay, oops. I see what I did. Okay, know what I did here, but all right. So we got that one. I need your help with the others, with the other sizing. So we sized. So let's go size the disconnect. Number three. Number three. Disconnect guys, I take 1.25. I need somebody to do the math for me because I did not do the math for this. 1 1.25 times 16 16.7. We did this math. 20.9 amps. And then you take the 20.9 amps, you take it to the watt. We went to the disconnect 3-12, 3-12. You came up with, we will come up with 30 amp non-fused disconnect. 30 amp non-fused disconnect. Number four, that's my disconnect. Number four is the equipment grounding conductor. Equipment grounding conductor. That's piece of cake. My equipment grounding conductor was my overload was 25. You take the 25 amp to table 250.122. Would that give me number 10? Anybody? With 25? I believe it's number 10. Number 10. There you go. 25 after is number 10. So this is also going to be one conductor number 10 AWG in an MB cable. That will be part of your NMB cable. That will be part of your NMB cable. Any comments, guys? Any questions about that? Okay, the last one, and I promise this is the last one, is this. We have a garbage disposal and a dishwasher, and we're going to do the same thing for one garbage disposal, one dishwasher, shall we? So if you guys take a few seconds to sketch, this is the last example that we have. We have a garbage disposal and a dishwasher, 1 kVA, 120, both of them, 1.6 kVA, 120 single phase. We need to size the disconnect, the overcome protection device, and so forth. Take a few seconds just to sketch them. Okay. Cool. Promise next time to give you a copy of the diagram at least. Makes it easier. Okay, so I have a garbage disposal dishwasher connected to a system. I need to size the overcome protection device, the branch circuit, the disconnect, and the equipment guard conductor. No controller, no overload. Why? Provided by the manufacturer. So let's go ahead and size the first thing. So let's start with the branch circuit for my branch circuit, guys, for my garbage disposal. Is that what we're doing? Yeah, for my garbage disposal. The first thing you need to do is find the amps. So let me grab, yeah, it's a red. So I have my amp equal. It's a 1 kW, 1K divided by 120. So 1000 divided by 120 give me 8.3 amps. Then it's continuous load 1.25, multiply it by 8.3 amps, and that will get you at 10.4 amps. This reference for this is 422.108. That's a continuous load. Then you take a 10.4 amp. You're going to take it to table 310.15 B16, 60-degree column. That will get you number 14.2 and MB cable. 14.2. So you need, for this load, you need 14.2. For the overcome protection device, guys, the same thing I would do is continuous load 1.25, even though it's a motor. You have the horsepower, you could go higher than that, but 1.25 continuous load with overload multiplied by 8.3. That'll get you 10.4 amps. Then you take the 10.4 amps, take this one to 240.6. That will get you a healthy 15 amp single pole circuit breaker. 15 amp single pole circuit breaker. I know ours, I told you guys the garbage disposal that we have, we're going to put at 20 amp circuit. We just put higher than what and because we did not hardwire it, we actually put a plug in it. So we have a 15 amp. If I know what the size, I could have gone with 15 amp number 14. Continuous load. Cool. Next, we need to go find the disconnect. Disconnect. What I do personally for the disconnect, my friends, is same thing. I take the 1.25 continuous load multiplied by my disconnect is 8.3 amps. The motor give me 10.4 amp, and then you take the 10.4 amps. This is from 422.30.31, I believe. That will get you guys 15 amp snap switch. 15 amp snap switch. What is the snap switch? You're looking at it right here. So 15 amp snap switch. Right? That's a 15 amp snap switch. Because if you guys go to 422.31, it will tell you you can use the snap switches to disconnect the garbage disposal. The plug also can be your plug also can be a disconnect. Your plug can be also a disconnect. Okay. Okay. The last thing is the equivalent ion conductor for this board. The equivalent ion conductor does the 20 amp, the 15 amp that we got. My 15 amp overcurrent protection device was, oops, my overcurrent protection device was 15 amps. You take the 15 amps, table 250.122, right? That will get you one conductor, number 14, AWG, and an MB cable. So your equivalent ion conductor will be the number 14. Almost done. Let's go to the dishwasher. Any questions about this? Straightforward? Yes. Karen, Derek, cool. So let's go to the dishwasher. My dishwasher, guys, is 1.6. So I need to do the math for the dishwasher. My dishwasher, I take I, find I, 1.6K divided by 120. That's healthy. That will get you a healthy 13.33 amps. Multiply continuous load, multiply by 1.25 times 13.33. That will get you 16.6 amps. You take the 16.66 amps to table 310.15 B16 under 60-degree column. That will get you a healthy number 12.2 NMB cable. 12.2. Came up with 12.2. Piece of cake. Continuous load. That magic 1.25, guys, continuous loads. Okay, the overcam detection device. Am I going too fast? Too slow? Too... Go back. There you go. So 12.2 NMB cable. That's it. Now let's go to overcam detection device. The same thing, guys. Very, very clear. So I want to take my 1.25 multiply it by, what's the full load current of that board? 13.33 amps. That'll get you a healthy 16.6 amps. And then you take this one, 16.6 amps, take it to 240.6. That'll get you a healthy what? 20 amp single pole circuit breaker. 20 amp single pole circuit breaker. Done. Disconnect. For disconnect, guys, the same thing. 1.25 times 1333, 16.6 amps. That will get you a 20 amp disconnect, and the type is that we use is plug. So we have a plug that's rated for 20 amps. The last thing is equivalent arc conductor. You take the overcurrent protection device, which was 20 amps, take it to table 2, 50.1, 2, and another 2, and that will get you one conductor, number 12 AWG, in an MV cable. Done. So that's how you size, guys, for garbage disposal, dishwasher, fans, and water heaters. So I hope that was a review from what we did yesterday. So I hope the more we do them, the more it emphasizes in your mind, guys, that every time you have a load, you have to ask yourself, I need to size the overcome protection device, the branch circuit, the disconnect, the overload, the equipment ground conductor. What I didn't size here is the conduit. But you guys went through the conduit. You can easily size the conduits, but we're not using conduits anyway. We're using cables here. NM cable. But if it wasn't an NM cable, then you have to size the conduit. Any comments, any questions? My expectation, guys, from you for the test is to write these rules on a piece of paper, write them for each one of these equipments, bring them with you to the test, and just apply them. Cool? So that's all what I have for you guys. If I